Good morning, my geometry thugs. We are going to do section 6-2, chapter 6, section 2, lesson 6-2, and it's titled Altitudes and Perpendicular Bisectors. It starts on page 234. In Braille, it's 234 straight up. There's a what'll you learn section, and then down towards the bottom of the page, it starts out with the first bit of important information about this chapter and a definition of altitudes. So if you could find page 234, 6-2, altitudes and perpendicular lines. So down at the bottom in Braille, up at the top in print, it says, in geometry, an altitude of a triangle is a perpendicular segment. So those are words that you've used before. Perpendicular means at a right angle. Segment is just a portion of a line. So an altitude of a triangle is a perpendicular segment with one endpoint at the vertex and the other endpoint on the opposite side of that vertex. And then there's a drawing on the next page that says the altitude line segment AD is perpendicular to the side BC. So if you turn the Braille page, and then print users, you're looking at the drawing directly below that little paragraph of information at the top of page 234. On 234A in Braille, you have a triangle with the top vertex is A, the bottom left vertex is B, and the bottom right vertex is C. And that's the outline of your triangle. This looks to be a scalene acute, or an acute scalene triangle, 3 different sides, and all the angles look to be less than 90. From the vertex A, there is a perpendicular heavy dotted line going through the midst of your triangle to the side opposite vertex A, to side BC, and there is a right angle indicator showing that that line is perpendicular. And this line on the interior of this acute scalene triangle is the altitude. Another name or synonymous with altitude is the height. Altitude means the height of something. So this is the height of the acute scalene triangle. On the next several pages are constructions to creating an altitude. And again, we're going to do constructions in the late spring before we do the end of course exams. So you can turn several Braille pages, Braillers, to 235A. And print users were on page 235 looking at the highlighted blue bold box. And it's going to detail the altitudes of 3 different triangles. We'll be on 3 different pages, Braillers. The first triangle shows an acute triangle, possibly an acute scalene, but there's no tick marks on it. But all angles are less than 90. And notice that the altitude comes from that top vertex, perpendicular down to the side opposite its base. And that's the altitude, and it's on the interior, the inside of the triangle. So the altitude is on the inside of a triangle of an acute triangle. The next Braille page, and the next drawing to the right in print, there is a triangle on this page, and it's a right triangle. Notice that we have a right angle indicator. The left leg, that perpendicular leg to the base, is a heavier dotted line, and there's an arrow indicating to it and off to the right that that is the altitude. So it's important to note that on a right triangle, the altitude is one of the legs that indicates the height of your triangle. It's the leg that comes from that top vertex perpendicular to the base. So you don't need an extra line for a right triangle. You already have the altitude because you have a perpendicular line, a right angle. So you know the height of your right triangle looking at that leg. So the altitude is the side of a triangle in a right triangle. On the next Braille page, 235C, and the next drawing to the right, this shows an obtuse triangle. So you got to really make your way through this drawing. There are three sides. It's an obtuse triangle, and then there's a heavy dotted line perpendicular to an extension of a dotted line for the base on the right of the triangle. And this is showing that in obtuse triangles, you can't have an altitude on the inside of it. It would be impossible to draw a perpendicular line from the vertex to the base on the inside of the triangle. So the base has to be extended with a dotted line, and then from that top vertex, there is a line that extends down to be perpendicular with the extension of that base, and there's a little right angle indicator. So basically you're feeling kind of two triangles next to each other that get created by that altitude. But you'll notice then that that altitude on the outside of your obtuse triangle is indicating its height. So the three distinctions that you need to be aware of is for acute triangles, the altitude will be on the inside. For right triangles, it will be a side of the triangle. And for obtuse triangles, it will be on the outside of the triangle. Right? So the next examples have you just identifying whether a line, a segment, is an altitude or not. So on 235D, and in example 1 on print in the middle of page 235, there's a triangle XYZ. This is a good example of showing you that a triangle does not have to be positioned so that it's quote-unquote upright. This is rotated, but notice that X is the top left vertex, Y is the top right, Z is the top right, and Y is the bottom. From vertex Y, there's a heavy dotted line going through the midst of the triangle, and it's connecting with the point W, and there's a right angle indicator. That is the altitude of our triangle. If we were to rotate our triangle so that it turned and sat on its base XZ, it would be as tall as from Y to W. And the vertex to the side opposite matches the definition. Along with it has to be perpendicular, so there's a right angle indicator. So this, it says below the triangle that segment YW is perpendicular, EDP, to XZ. Y is the vertex and W is on the side opposite of Y. So YW is an altitude of the triangle. So this is a yes. That definitely identifies the altitude. On the next triangle over, we have an obtuse triangle, ABC. A is at the top, B is the bottom left, C is the bottom right vertex. There is a line extending through the midst of our triangle from vertex A down to point D on side BC. That is not an altitude for two reasons. First, there's no perpendicular indicator. That line AD is not perpendicular to BC at all. It's at a slant. And also by learning that this is an obtuse triangle, you know that the altitude needs to be on the outside of your triangle to show its height. So you would have to extend the base to the left and then draw a line from vertex A perpendicular down to the extension of the base in order to show its height. So this is a no. AD is not perpendicular to the segment, so AD is not the altitude of the triangle. The next drawing on the next Braille page, and immediately to the right, number 3 on print, shows a right triangle that's been rotated. And the heavy dotted line is from vertex M to P. M is in the top left, P is the top right, N is the bottom right. There is a right angle indicator at vertex P. So MP is the altitude because this is a right triangle, and if it was rotated 90 degrees to the clockwise, to the right, it would be sitting on its base NP, and MP would be indicating its height. So this is another example that the triangle doesn't have to be in perfect position to notice that it has a height and matches the definition. So this is a yes. This indicates altitude. And down below the drawing it says MP is perpendicular to NP, M is a vertex, and P is on the side opposite of M, so MP is an altitude of the triangle. Right. You turn the page, it has a couple of examples in Braille, and if you look directly below those examples in print, it asks you whether It's indicating altitude or not on these drawings. So the first little letter A, you have triangle DFE. D is top left, F is top right, and E is bottom left. There is a heavy dotted line extending from vertex D through the midst of our triangle and joining at point G. Is that an altitude or not? The answer would be no, because it's not perpendicular. There's no perpendicular indicator from D to G. If they pitched it one way, kind of down a little bit, and put a perpendicular indicator, then it might be. But this is not an altitude. The next drawing below that, on little letter B, and to the right in print, we have triangle RST. R is the top right, S is the bottom left, T is the bottom right. There's a heavy dotted line coming from vertex R, perpendicular down to the extension of our base, ST, with a right angle indicator. So this is a yes. It's an obtuse triangle showing its height on the outside of the triangle, showing its altitude on the outside. The next drawing to the right in print, and the next page over in Braille, on page 235 H, is triangle HGI or GHI or GIH, however you'd like to say it. G is at the top, H is at the bottom left, and I is at the bottom right. There is a heavy dotted line on the interior of this triangle. This looks to be an acute triangle. From the vertex G to the side opposite HI with a perpendicular, a right angle indicator, and it's connecting with point J. And this would be a yes. It's an acute triangle. The altitude is on the interior, and it's perpendicular from the vertex to the side opposite. That's just the lunch bell, not the bell to leave class. All right. Then it says below this triangle that we need to read some information about something else we need to learn in this section. So we've learned about altitude. Now we're going to learn about perpendicular bisectors. It says another special line in a triangle is a perpendicular bisector. A perpendicular line or segment that bisects a side of a triangle is called the perpendicular bisector of that side. Line M is perpendicular bisector of side BC, and that's on the drawing immediately to the right in print and one page over in Braille. There's a drawing that indicates an altitude and a perpendicular bisector on the same triangle. So we have a triangle ABC. The top vertex is A, the bottom left vertex is B, and the bottom right vertex is C. From the vertex A, there's a heavy dotted line extending to the side opposite BC, and it has a right angle indicator. So we know that that's the altitude. It's labeling that to the left, that line is the altitude. Then to the right of that line is a line segment. There is a line. It's line M. They've labeled it up at the top with an arrowhead and then a line going through it. They missed the arrowhead at the bottom. It's going through a point D, and it also has a perpendicular indicator. It's not coming from a vertex going through a point. It's just going through our triangle at a perpendicular line, and it's bisecting the side that it's going through. And to bisect means to divide in half. So D is the midpoint. This is called a perpendicular bisector, and they're indicating that, they're labeling that off to the top left with an arrow pointing to that line. So that's the difference between an altitude and a perpendicular bisector. Notice that it's going through the triangle. It's not bisecting the triangle. It's bisecting the side that it's perpendicular to. And it's not necessarily coming from a vertex. However, it can come from a vertex. And on the next page, we will see that. First, it says in Braille on this page, there's a page break for page 236. And print users, you need to turn the page. But it says in the paragraph of information before we look at the drawing, it says in some triangles, the perpendicular bisector and the altitude are the same. If the perpendicular bisector of a side contains the opposite vertex, then the perpendicular bisector is also an altitude. And we'll discover and prove later that this is going to happen with isosceles and equilateral triangles. So turn the page, Braille users, and you'll see the drawing for this. Print users, we're looking at the drawing immediately below that paragraph of information. So we have a drawing with Y as the top vertex, and then the bottom vertex to the left is X, and to the right, the bottom right, is Z. So we have X, Y, Z as our triangle here. And we have an altitude extending from vertex X through the triangle, perpendicular to the side opposite, XZ. And it's meeting at point E. And that's indicating that that's the midpoint of XZ. And so that line containing that's perpendicular is the bisector and the altitude at the same time. And it has little keys for you in Braille and explaining that above the drawing, that it's the altitude and the bisector. So sometimes they'll share both, and we'll prove later how and why that happens. So if you turn the Braille page, and print users, we're looking at examples 4, 5, and 6 down below, we're going to tell whether each red line or heavy dotted line is a perpendicular, bisector, and altitude, or both, basically. So this first one, example 4, shows a triangle. It has the top vertex at C, the bottom left vertex is D, and the bottom right vertex is E. It's rotated slightly from its base. And there is a heavy dotted line with arrowheads extending through the triangle. And that's coming from vertex C to the side opposite, DE, at point F. And there's a right angle indicator, and then there's a tick mark from D to F, and a tick mark from F to E to show congruency. So that shows that then if DF equals FE, then we know F is a midpoint. It's divided our DE in half. And then we also know that this is perpendicular because the right angle indicator. So by definition of altitude and definition of perpendicular bisector, we know that this line CF is both. It's the altitude because it extends from the vertex at a 90-degree angle to the side opposite, and it's a perpendicular bisector because it divides the side opposite exactly in half, and that's indicated by the 2 tick marks. The next drawing on the next Braille page, and one down in print, example number 5, we have a triangle X with our top vertex, Y at the very bottom, and then Z up slightly to the right. Oops, I wrote an R instead of Z on my drawing. And then back up to X. So we have X, Y, Z. From vertex Z is a heavy dotted line extending to the side opposite XY with a perpendicular indicator and at point W. Now, notice there's no tick marks. Also, you probably can feel the difference. From Y to W is less than from W to X. So we know that that line coming from Z to W is not bisecting XY. So that's not a perpendicular bisector. But it is a perpendicular line from a vertex to the side opposite at point W. So it is indicating the height of this acute scalene triangle. Okay? All right, the next page in Braille and the next drawing down, number 6, is showing again a triangle with a line going through it. We have point A at the top left, point C at the top right, and point B at the bottom left. So we have our triangle A, B, C. There is a heavy dotted line going through the midst of our triangle with arrowheads extending in both directions. It's going through they're indicating at point E on the right and point D on the left. It has a right angle indicator just above the line, so it's indicating that that line is perpendicular to side AB on the left. From A to D is a tick mark, and from D to B is a tick mark. So that's showing that AD is congruent to DB. So knowing all that information, knowing what you've learned in previous chapters about tick marks and midpoints and bisectors, you know that AD is congruent to DB, Therefore, D is splitting AB exactly in half, so we know D is a midpoint. This line is perpendicular to AB, so we know that it's a perpendicular bisector because it's splitting AB in half. It is not an altitude because it's not coming from a vertex opposite the side to create an altitude. So this is just a perpendicular bisector. All right, turn the page and your turn. There's a couple of choices for you to identify what these are. Are they perpendicular bisectors? Are they altitudes? Are they both? So the first one, little letter D, shows a right triangle with point R at the top, point S at the bottom left, and point T at the bottom right. There's a right angle indicator at vertex S. A heavy dotted line is on the side RS. So we know this is a right triangle. We know that altitudes of right triangles would be their sides from the top vertex perpendicular to the bottom side opposite. So if RS is an altitude, RS is not a perpendicular bisector. It's not bisecting anything. It's just the side of the triangle. So this is a yes to altitude, a no to perpendicular bisector. The next triangle down in Braille on 236E, and then triangle to the right on the bottom of page 236, it has a top vertex of M, a bottom left vertex of N, and a bottom right vertex of P. There is a line extending through the triangle perpendicular to ND at point R. So this is a perpendicular line, yes. It's perpendicular to ND. That's the third bell for lunch there. ND. Notice that there are no tick marks from N to R and R to D. NR is substantially less than RD. So this line is perpendicular to ND, but it is not bisecting ND. It's not dividing it exactly in half. So this is a no to perpendicular bisector. It's also a no to altitude because it's not extending from a vertex. It's not extending from vertex M to the side opposite. So this is just a perpendicular line going through our triangle. It's neither perpendicular bisector or an altitude. Turn the Braille page to the next drawing, and print users look immediately to the right to little letter F. We have our third triangle to practice, identifying perpendicular bisectors or altitudes. We have a point Q at the very top, point R at the bottom left, and point S or vertex S at the bottom right. So we have QRS. There is a line extending from about the 9 o'clock to 3 o'clock position through the midst of our triangle, a heavy dotted line with two arrowheads on each end, and a right angle indicator. And it's extending through side QR and QS, and through side QR it has the right angle indicator. There's a tick mark, and it's intersecting at a point they're labeling T. There's a tick mark for segment QT and a tick mark for segment TR. So that's indicating that QT is congruent to TR, equal to TR. So we turn our brains on and go, aha, they have split QR directly in half. This line is perpendicular to that side, therefore I know it's a perpendicular bisector. So it's a yes to a perpendicular bisector. It's a no to an altitude because it's not coming from a vertex. So all it's doing is bisecting a side, right? So that is the remainder of 236. Then there's a page break in Braille to 237 that discusses a story problem about an interesting stringed instrument, a balalakai or something it's called, I think. And it just says it's a stringed instrument that has a triangular body. They're commonly played when performing Russian songs and dance music. A 3-string balalakai is shown at the right. Tell whether string B is an altitude, perpendicular bisector, both, or neither. So on the next Braille page, they have a drawing of this instrument. In print, they have a photograph. Excuse me. So notice that it creates a triangle at the base of this instrument. It's got like a triangular shaped body where they label the top vertex J, the bottom left vertex H, and the bottom right vertex I. And then going through the midst of it, they're labeling that the string B. There's a line going through that's perpendicular. So it's coming from vertex J, and it's perpendicular to the side opposite HI. And since it contains the vertex J and is the side opposite HI and is perpendicular, we know it's an altitude. Now we have to determine if it's a perpendicular bisector or not. And the opposite it is, because we can assume, hopefully it didn't tell us, but that because this is an instrument, it's probably congruent. So the side JH and the side JI are the same. And so therefore, it's going to extend down through this isosceles triangle at minimum, possibly an equilateral triangle, be perpendicular to the side opposite. It is going to split HI in two. This is a little bit of a rough one because it's making an assumption that you might know some things about some musical instruments and could make some conclusions and assumptions based upon that. I would argue that it would be nice if there were some tick marks to remind us that those were congruent. But it is both a perpendicular bisector and an altitude. All right, that's the end of section 6-2 as far as the information and lecture is concerned. For practice, you can work on the check your understanding. I would advise that you do at least number 3 through 7 to practice what you've learned, and to do extra practice, you could work on numbers 8 through 20 on page 238. Identifying altitudes, perpendicular bisectors, whether they're both or neither, in different positionings of triangles, and remembering the definitions of each and how you would identify them in regards to whether the triangle is acute, obtuse, or a right triangle. All right, that's it for this lesson. We'll see you in the next one.